So, I told you last time this is the way I like to set it up on a test or a quiz or something. I'll actually tell you what the derivatives should be. So if you have any major trouble getting those derivatives, at least you can still do the work because you'll know what they should be. Right? You can still do the sign diagrams. You can find out where it's increasing, decreasing, all that kind of stuff. So we left off, we found the critical numbers from part D. Just kind of catch up to where we were. So part D, we had this. So part E, we found the critical numbers were x equal to 0 and x equal to
plus or minus or 1 or 2.
Yeah, 1 over root 2. Cool. So now all I had to do was make a sign diagram. So this is going to be... Now notice the multiplicity for these would be what?
1 of each. 1
for each one. Because if I broke this down, it'd have a first degree for both parts. If I did break that down. So it's kind of nice. So I really, thankfully, because the numbers are kind of ugly, to try to get something in between these things, I really just need one value to get me started. It's 0 at each of these. So at 1, if I knew the sign there, then I know the sign everywhere. So at 1, the sign for the second derivative, would it be positive or negative? Negative. Yeah, because this would be negative times positive. Good. So it's negative out there. Then it's got to change sign everywhere because they're all multiplicity 1. Cool. And this is the second derivative. So what could I draw associated with this? I can't really draw a sketch of the graph, but I can show the concavity. So here's concave up. That's crazy. Down. Up. Down. So each of these turns out to be an inflection point. I love it. So max or min are where it goes from increasing to decreasing. Inflection points are where it goes from concave up to concave down. Cool. So to find the inflection points, 1 divided by square root of 2 is roughly 0.7. This sounds familiar. I thought we made it this far. I can't remember now. So it's, this point would be negative 0.7, roughly, comma, whatever the hell. Where are you going to put this at, by the way? I don't have my function here. Give me get away, but anytime you want to find the actual point, you got to use the actual function. Good. It's a little weird in the middle of a problem to be careful to catch yourself that you're not putting in the wrong place. So my function was this. Cool. Thank God they invented a calculator so you can just plug in 1 over radical 2, negative 1 over radical 2 into this guy. Somebody can, there's a whole mountain of calculators here. That should help me out.
What do we got?
Yeah. Say again. 1.2?
Oh, because
my batteries are low.
No quiz today. Oh, no, the quiz is Monday. That's what I thought.
So negative 1 divided by square root of 2.
From what section of what? I don't know.
Cubed minus 3 times.
What are we plugging into the calculator, sorry?
So we're trying to find that first inflection point right here. Alright. So after all that time, I catch up to what you said. So negative 1.2 blah blah blah, and you can just round it to 2. Cool, I like it.
So we just plug in the negative 0.7 to the f of x?
Yeah, and be real careful. I mean, you have to be a little bit careful because if you round that much, depending on your function, it could throw the result way off. You don't want to put the rounded result into your function. You put this in your function.
Okay. And
you got a calculator, so it's not a problem. You round the results afterwards. Okay, so be a little careful. Here it didn't really change at all, but you got to be careful. What's this going to be then? Anybody can tell me this will be 0.7? Yeah, because it's so you guys see this
opposite.
These are odd powers, so if I put a negative function value in, it's just the negative of what the positive value would be. I don't know if you guys can see that. So this will be positive 1.2. And then 0, of course. Awesome. So those are my 3 inflection points. So I got 3 inflection points. You guys help me summarize what we know here from part C. The max was. Somebody have their stuff from last time?
2 and -2.
1 and 2.
2 and -2.
So 2, -2?
No, 1,
No.
1, 2.
Yeah. 1, there you go, that's better. 1, 2, -1, -2, that's awesome. Mid? Or were those both, those were both. Alright. So this is the max. You guys really have to, so max is this, the min was this. Thank you, cool. Because I don't have my sheet from last time. Alright. So we got the maxes, we got the relative extrema, we have the inflection points. And that's really, when I was taught this, I was taught to look at the intervals. And it's almost impossible to keep track because you have increasing and then somewhere in the middle it changes concavity. So personally, it's much easier if you plot these important points and just label them. And as you go, you know exactly what to do at that point. So you have a max at 1, 2. Oh yeah, that's right. We did get. I just didn't make my scale big enough. That was it.
Yeah, you put a bunch of points on there.
Yeah.
Yeah.
So let's make my scale like that. 1, 2, -1, -2. So this is a min. This is a max. -0.7, -1.2 is an inflection. 0.7, 1.00 is an inflection. 0.7, 1.2 is an inflection. Crazy stuff. And let me think. Did we get the intercepts were? I can't remember if we did this. Did we do the intercepts? So for part of F was I'm sorry, G. Find the intercepts.
Intercept was 0,
0, 0.
and then plus or minus root 5/3.
I like it. Oops. Cool. Yep. And that's roughly whatever the hell. I think that's the point where I was.
It was like 1.6.
Yeah. I was trying to do it in my head, which is painful. Square root of 5/3, what is that roughly?
4.6.
1.6? Thank you. So you got to intercept at plus or minus 1.6. Roughly right there. Okay, cool. There you are. Okay. So, you got your end behavior. I talked a little bit about that. Your end behavior for this is going to be that negative cubish dude. Yeah. So it's got to come in. It's got to come in like this. It's got to go down and hit a minimum, and it's concave up. Right. So I can just barely show that. That's why this should be even more expanded. But oh, too bad for me. Concave up, and then it's got to become concave down in between. See, that's my inflection point there. So now it's concave down from here to here. Everybody still with me? So that's why if you label the points, you don't have to worry about the intervals where things happen. You have to write those out for me. But you just, as you hit a point, the point tells you what the hell to do there. Since this is an inflection, I want to change over to concave down. That's an inflection, so now I'm changing over to concave up. And that's an inflection, so I'm concave down. And I really needed to give myself some more room here. It's too bad for me. And then I can turn around and come back down there. So what I should have done is blown up that x-axis again. I blew the y-axis up. I should have blown the x-axis up.
So the whole point that we did the inflection points was to find exactly where the dots are going.
Where the concavity changes.
Okay.
So here it's concave up. All the way to here it's concave up.
And the inflection points were found by taking the second derivative, right?
I love it.
Okay.
Good. So concave up, concave down, up, and then down. Cool. You can always double check it on the calculator, but calculator, sometimes you can't really see the changes in the concavity. That's why the calculus is good to know where those are happening. Okay.
What those intercepts by your elbow for G?
Yeah, actually.
What did we do there? I didn't see that part.
So you set the original function equal to 0. Find your x-intercepts. Plug a 0 in. Of course, that's just one of your x-intercepts. That's your y-intercept automatically through the origin.
Can I say where we have the 0.7, our inflection points of the x values, do we plug those into the original function or to the first derivative?
Anytime you want to get a point to actually plot, it has to go into your function, because your function is the one that controls where your outputs are, where your function is.
Okay.
Everything else controls some aspect of what it looks like. Yeah.
So that graph's just a graph of the original function.
I love it. So we used this information to graph the original function. At no point am I going to ask you to graph like each derivative. We did that before. Now we want to use the derivative information and the second derivative information to get a better graph by hand of the original function. So in pre-calc, you didn't have to worry about it because you didn't know what the hell it was, concavity and all that stuff. So your graph could end up looking different, but all you worried about was you got all the locations of everything in the asymptotes. Now, you almost want to overstate like I did. Just to make sure that I can tell you know what the hell you're doing. You want to overstate your concavity maybe a little bit. Don't make it look straight. Do you see what I'm saying? Because I will have to take points off if it's supposed to be concave up and you have a straight line. you know what I'm saying? So you got to be careful. Because at the end, I always have students that would do, this, and then suddenly this is a straight line forever. That's never going to happen. It's got to have some kind of a curvature to it as it goes up. Yeah.
The last one, plus or minus 1.6, where did that come from?
Just an approximation of the square root of 5/3. So hopefully.
I got 1.29.
Oh, okay. Somebody said 1.6 and I went with it. That was my mistake. Okay. So that should be even more in.
Okay, I was going to say, because the graph was like really curved.
That's all right. You guys tell me. If you notice I'm not putting it in the calculator myself, you should double check.
To find the x-intercepts, I know this is pre-calc kind of stuff, but I just want to triple check. You just flip the y and the x, right?
Find the 3 is 1.6. Yeah. Say it.
Oh, so I just want to triple check. To find the x-intercepts in this case, we just flip the y and the x, right? And then try to find the zeros for x, right?
Make your y 0.
Yeah, you just set this equal to 0.
Oh, okay.
Yeah, to find the y-intercepts, you make x 0. To find the x-intercepts, you make y 0.
Okay.
Yeah, and that's where you factor this thing. Almost always you factor it to find the intercepts. Yeah. Okay. So coming off the heels of that, unless you have any specific questions from homework or from this problem.
No, not from the problem. I was going to ask what sections the quiz is going to be on.
So the quiz next time is going to be a quiz on Monday. It'll definitely have stuff from 3. Which one was it? 3.
10 or 11.
10 was the linear approximation one. I'm not too concerned about the hyperbolic stuff. I think I got that across to you guys. Yeah, 310. And then 4-1, 4-2, and 4-3.
Are you still going to test Wednesday, or are you pushing it back?
No, I already pushed that sucker back.
Oh, okay.
You guys remember that?
Yes.
Where did we push it to?
To the next Wednesday, which will be the Wednesday after spring break. Yeah. Yeah. I'm not going to push it to the Monday after spring break because I just am not evil enough for that.
Is Monday going to be the study
The
session?
review. Yeah.
The review.
So next Wednesday I'll give out the practice test. You'll have all the spring break to avoid doing it until you do Sunday night. Sunday you do it. And then Monday we'll have the review. Yeah. Oh wow. You're right. I was giving. Yes, right.
We're not that smart.
Okay. So any questions from homework or anything before we? So I'm going to skip 4-4 for right now. I'm going to come back to it right after this handout, by the way. 4-5 is essentially the same thing as 4-3. It just brings in pre-calculus stuff more predominantly. So you're going to have possibly some rational functions that you have to look at the asymptotes. You might have horizontal asymptotes, vertical asymptotes, or you might even have slant asymptotes. So you got to remember those. You're going to have symmetry possibly to look at, so forth. So I want to do a real quick. This one doesn't have any asymptote stuff or anything, so but I just thought it's a nifty function to work with. This will also continue to review section 4.3.
I think it's just kind of local maximum. I don't know. I have no idea.
So there's no max or min on the side of the ratio if it's 1 or negative 1?
No, it does it.
Does it?
Of course.
So
Sine of 1 is 1. So there's not open circles there or something.